Inequalities involving quadratic functions. Let's take a look at number A. A says, solve f of x greater than or equal to 0. So this graph here is f of x here. And we're looking for f of x greater than or equal to 0. So that's where my y value, because f of x is equal to y, it's where my y is greater than or equal to 0. So here's my y-axis here. That's the y-axis. And I'm looking where my y is greater than 0. So that means I'm going to be above the x-axis. That's what I'm really looking at here. So, and it also says equal to. So that means I'm not just looking at where I'm above the x-axis, but also on the x-axis. So when I look at this graph, let's say I take this red piece here. I can see that that's below the x-axis. And that means my y values are negative there because down here is negative y values. So since we're dealing with the positives, we can't include that chunk there, that little piece. And again, when we're talking about intervals for the most part, when dealing with functions, we talk about those intervals in terms of x. So if I look at this graph in terms of x, am I going all the way left? And I would say yes. Am I going all the way right? No, because I'm going to stop here. Here at, what is it? 3 or 2. That's at 2. And then if you look at this on the other side, then I'm going to pick up at 4 again and go to infinity. So these are going to be infinities on the left and the right because that is where my graph is above the x-axis at, and also equal to too. So we're going to show you, I'll show you how to include that as well. So let's put that all together now. So I know I'm going to be all the way to negative infinity because my graph is going to be above the x-axis there. So I'm going to write negative infinity. And then it's going to go all the way to 2, and it includes the 2, so I use a bracket. Now, to include the other interval, I simply I could use a union here. And then, since it says equal to, I can include the 4 as well. So I'm going to have another bracket and then a 4, and then it's going to go to infinity because it goes all the way right. And it doesn't matter how far right I go, my graph is going to be above the x-axis. And that's what it means to be for y to be greater than 0. Okay, so that's the first answer there. I just solved it with using that interval notation. That's my solution. It's not like an x equals like we're accustomed to. This is what we end up with. Okay, let's take a look at number B now. Number B says x squared minus 5x plus 6 greater than 0. So what I'm going to do first here is I want to find out where this boundary is at for this function and graph this function so I can do the same thing I did with A. I could easily see where I'm greater than 0, less than 0, or equal to 0 if need be. But this one here says greater than 0. So that's what we're looking for here. So we're going to graph this first. So right away I'm going to try to find x squared minus 5x plus 6 equals 0. And I'm going to try to find the vertex because a vertex is necessary when we're graphing a parabola. So that's x equals negative b over 2a. So that's going to result in, and I'll write it down here, my b is 5 negative, so I'm going to write a positive 5 there. I have a 2 down here, and a is 1. So my y-intercept, I don't like this y-intercept. My x value is 5/2. I don't like that. And plugging that in my original function, my function being f of x equals x squared minus 5x plus 6, what I'm saying here is f of 5/2 is going to equal negative 1/4. And I just plug that in. X for x, 5/2, and then I find out what that value is, and it's going to be negative 1/4. So there's my ordered pair for my vertex. Another thing I'm going to use here is my y-intercepts. Now for this one, I can actually just factor it. because I'm looking at where this thing equals 0 at. Oh, it's interesting. I shouldn't have had that 0 there before that, but that's okay now. Just my notation was bad. Let me take this off right now. Because I wasn't solving an equation there. I was just graphing this one here. I apologize. Okay, so anyway, so now I actually want to set it equal to 0. So now we're going to factor this one. And this is going to be x minus 2, x minus 3 equals 0. And we can see that my x equals 2 and 3. So between 2 and 3 are my x-intercepts. What is my y-intercept? I just plug in 0 for x, and that's going to make this 0. It's going to make this 0, and I'm going to end up with 6. So again, I'm just racing through this information quickly. So at 0, 6, 1, 2, 3, 4, 5, 6. I hope this isn't too overwhelming for you. That's my y-intercept. My x-intercept is at 2, which is here, and 3, which is here. And then my vertex is 5/2, which is 2.5, which makes sense. It's right between there. And it's -1/4, so it's almost at the x-axis. It's just below it by 1/4. It's -1/4. And then now I have symmetry here. So that means from the center here, if I went 2 over, that would put, well, 2.5 over. Oh, hang on, 1, 2.5, yep. So 1, 2.5. So that would put a point there. Yeah. Now I can actually graph this thing, and I will. All right. Now this would be enough for a graph. I just wrote extra here just to make sure we have everything we need. Okay, now this is the actual graph that we're looking at here. We did our y-intercept, x-intercept. We did our vertex, and that's enough. That's enough to determine the answer for this inequality. So now what we get for this answer is we're looking where this function is greater than 0. And that's going to be above the x-axis because that's where this is really my y or my fx here. If you think about how it's set up, like down here, f of x equals that. So this function here is x squared minus 5x plus 6, and that's my y values. So where are my y values going to be larger than 0 at and above the x? So that's going to be from this value here all the way left, because remember, we represent these solutions in terms of x values. So that first interval is going to be from -∞, comma 2, and I'm not including the 2 because it doesn't say equal to there, just greater than. So it's going to be a parenthesis here, and then I'm going to do a union, and then it's going to be a 3 here, and again, I'm using another parenthesis because it didn't say equal to, it just says greater than. So I'm not going to include the 3, so I use a parenthesis. I use a bracket when I'm including it. And that will go to infinity. So there's our answer for those two. This is the answer for this one. It's the interval. And this is the answer for the other one. Now, for this second one here, make sure you show some work for this. Don't just graph it and say it's this. Show some work of how you got the graph.